So let's go look at these, see how they are. The first one, it was you. If you didn't get number one, it was because you overthought it. It's actually way simpler than you're making it out to be. So let me write this down. Don't feel bad because you're not alone. Um, just a minute. Let me just write down my function here. 3x squared minus 4x plus 4. Um, and h is equal to 4. It tells you f of 3 is equal to 19. I don't know why I would need that, but we're going to do it. Okay, so they want us to compute this. F of x, or no, 3, right? Mine was 3. So yours was whatever number you had. Mine is 3 plus h minus f of 3. So at first that's like, well, what are we supposed to do with this? Well, you're supposed to actually compute it. H is 4, so you're going to do f of 3 plus 4. Your h might be different from mine, so this will be f of 7 minus f of 3. And I've got my function up there, so just plug it in. 3 times 7 squared minus 4 times 7 plus 4 minus, they told us what f of 3 was, didn't they? So I don't have to compute this. F of 3 is 19. Presumably, if you plug 3 into that function, you get 19. So I'll just do this, 19. So this isn't too bad. This is going to be 147, 28, plus 4 minus 19. So what do we get here? 19, 28, that's 30, 47, plus 4, 104. Let's see if I did my mental arithmetic correctly or if I need more caffeine. 104. I guess I could just click this. Oh, I got it right. So that's it. That's all you have to do is just plug in the numbers and actually compute. I know, kind of dumb when you think about it. And actually, now that I think about it, I wonder, why did I even select this? Actually, what I do is I take their suggested problems and then I add or delete. This is probably one I should have deleted because it's kind of stupid. But there it is. That's all you have to do. Let's take a look at number 2, since that was a question as well, and then we'll see what other issues you have. So number 2, it says f of 3 is 9, f prime of 3 is 4. I want to estimate f of 2.9. Give me a sec here. So let me just show you what this is referring to. Hold on a minute. F prime of 3 is 4. Hold on a minute. Okay. So given this information, you could imagine a graph that looks something like this. Maybe not exactly like this, but I've got my function. I don't know what the function is. It may do weird things, but I do have the slope of the tangent line. That's f prime of 3. And I have the point 3, 9. It says that f of 3 is 9. So here's this point. Here's this slope. And it's asking me what is, or approximate the function value back here at 2.9. Well, I didn't leave myself any room to write anything, but that's okay, because I don't know what the function value is back there, but I could use this tangent line to estimate or approximate that function value. So that's all you have to do here is we will just compute the tangent line. Let me get rid of that f. I don't know why I put it there. So y, the straight line is what I'm going to use. So y is equal to 4. What am I doing here? I need to get rid of some stuff. I'm going to use the point slope form. Y minus 9 is equal to m times x minus 3. You can use the slope intercept form if you'd like. I don't care. So I get y is equal to 4x minus 12 plus 9. So y is equal to 4x minus 3. So that is this tangent line. And when you're pretty close to 3, the function values will be pretty close. So we'll just use the tangent line. So let's plug in 2.9. So y is equal to 4 times 2.9 minus 3. I'll need to use my calculator. I probably could do this in my head, but I'm not going to at this hour of the morning. Whoops. So minus 3. So I got 8.6. And that's going to be good enough. It's not going to be exact, but it didn't say to get the exact value of f of x. It just said to get an approximate value of f of x. So what did I say it was? 8.6. Let's see if it's right. 8.6. When I hit enter, actually I'm just going to do this, do the cheater version. Since I have the little key, I can check it out. There, so that wasn't too bad either. So these are just rates of change. We're using the rate of change to approximate a function, and kind of makes sense that if you're going up and down a hill, the rate of change doesn't change very much in a short distance, but it changes. It might change a lot if you go, a mile. So I wouldn't want to do this trick to approximate. Here, let me just show you on my picture. So I wouldn't want to use this trick to approximate maybe over here somewhere. Because notice that the straight line, it diverges quite a bit from the function, perhaps. But when you're pretty close to 3, you could use the straight line instead of the function. All right, what else from this homework caused grief? So I've changed the due date, so it's not 2030, but it's today, but it's not till midnight, so you have plenty of time to correct things if need be. But did you have anything else? Yeah, what do you think, Allison?
I have problems with question 7. I thought I did it right, but it said it's wrong.
All right. Oh, interesting. It's you did it right, but it said it was wrong. So let's check it out. Ah, yeah, this business. So this was similar. Someone earlier had a question similar to it. Yeah, I hesitated when I saw this, and I thought, I don't like it, but I left it there. So when I was selecting problems for this homework, so it is what it is. Let's see if we can work it out. So I don't know if your numbers are at all similar to mine, but it's probably a similar feel. So if after doing it together with these numbers, if you still don't understand, or we can do it with your numbers, because you probably have your numbers sitting right in front of you. So it says that after, let's see, the population currently, so I'm just going to write down the information here. Currently, the population is 15,000. And then in 8 years, the population will quadruple, which means you will have 4 times 15,000 or 60,000 in 8 years. And I want to know, what will the population be in 5 years? Okay, so I have all the information here that I need. It says that the growth is linear, which is not at all true. Well, I shouldn't say that. There are populations that grow linearly. In fact, the population in the United States has grown relatively linearly in recent history, I should say. So you look at the population of the United States, and it does something like this. It kind of goes, and then it just sort of levels off in terms of the growth rate. So we're kind of in this period. This was in the 1800s. It kind of just shot up, and then it started to, it's still growing, but kind of linearly. But anyway, getting back to this, let's go ahead and get a function. So since this is linear, this p of, we'll call it p of t, will be some slope times t plus the original population. So that's what it means to be linear, is that you have a nice line or first degree polynomial. I'm going to use this to figure out what m is. So you have 60,000 is equal to m times 8 plus 15,000. Suppose I could have just used the point slope form, shouldn't? Or yeah, I could have done it that way. Notice that you just do y2 minus y1 over x2 minus x1. That works as well. Well, anyway, we'll do it this way. This is 45,000 is equal to 8m. So m should be 45,000 over 8. 1,000 is divisible by 8. It's 125. So 125 times 45. Sorry, I'm going to use my calculator. 45,000 divided by 8, 5625. Okay, so my population at t is 5625 times t plus, what was the beginning, 15,000? All right, now I need to do p of 5. So I'm going to use my calculator for sure for this. 5625 times 5 plus 15,000. And there it is, 43,125 is what I'm getting. All right, let me check and see if I'm right. And then we'll see if you have questions about your particular problem, because it may be that you just left off a 0 or what have you. 43,125, I was right, good. So Allison, were you able to identify where you went astray?
Yes. I forgot to add back on the initial.
Excellent. So we found the problem. That's always exciting when you do that yourselves. Anyone else have issues with this one that we need to you no, yep, yes?
I did. I can't figure it out.
Okay, so did you follow what we did right here?
Yeah, and then I missed it, so I have the number.
So, oh, you have a different set of numbers?
Yeah, because I missed it.
Well, what are your numbers?
7.
Whoa. Hold on a minute. So you're saying, I'm just going to change colors here just a sec. Okay, so instead of 8, you have 7?
Yeah.
Okay, after 7 years, it quadruples.
Right.
What a pain. Okay, so we're going to change this to 7. What was your initial population?
15,000.
Oh, same as me. And so the quadrupling will be the same as well, 60,000. Okay. And then what is the number we're looking for?
1 year.
Oh, after 1 year. So there's the changes that you need to make. So, oh yeah, this is not going to be. Seriously, you have 7?
Yeah.
Why did they give you 7? I hate 7. Because look at this. What's going to happen with 7? We're going to get 45,000 over 7. That's not going to come out nicely. Thank you. Sorry. Let me go back up here. So these are the numbers you have?
Yes.
7? Sorry, I know. I had to repeat my my horror at having to do 7. 7 is not a nice number. I mean,
I can try to get another problem.
no. 3 is a magic number, but 7 is just, I know 7 is like perfection when you go to the Bible, but supposedly, God rested on the 7th day and all that, but I hate it in math. Okay, well, let's do this. So I've changed all of my 8s to 7s. And let's see if we get this right now. I changed that and I did the division on my calculator and I have this horrific number, 64285714. There is one cool thing about 7, but we don't have to dwell on that. Not yet. Maybe in a minute. It'll act as a salve for the thing that we have to do now. So 64,285.714, and that changes. And we're going to do this. Oh, we're going to do p of 1. Okay, so this is going to be 21,428. Wait, 5. Wait, do I have too many? My decimal place is in the wrong place. Yes, it should be there, not there. Look at this. Not only is Lumen leading you down the path to destruction, but apparently I am as well. Let's try that. Okay, anyway, all I did was I just did the same thing I just did, but with your numbers, with the 7, which I know. 7? Really? Okay, yes, I believe you. But there's the number I'm getting for P of 1. Type that in. Tell me if you get it right. I don't know if you should round to 29. Yeah, do it to 29, 21429.
That works.
Okay, it's gonna be all right. You know, sometimes I was in a meeting yesterday and like I heard something that I had to just have like a change of paradigm. Like, cause I went into the meeting thinking one thing, and then I'm being told a completely upside down thing. And then someone asked me, John, what do you think? I was like, I'm not ready. It's like, I'm sorry, I can't speak to this issue until I've, reframed. So, okay, 7. We got it now. We got the 7. We got it. We're good. You know, sometimes it just takes a nice deep breath. All right, are we done? Uh-oh, Kelsey.
I don't know how to do question 8. Oh, thank you. Thank you.
Okay.
This one you just overthink it. It's so much.
Same thing.
It's so easy. It looks confusing, but you just overthink it.
Okay, we're gonna so Bryce is gonna help us not underthink it. We're gonna underthink it now. So population in 4 days. So P of 4. I'm just gonna write down the information that is here, but I'm gonna write it in math. P prime of 0 is 4. Okay. So, and we want to know what?
So you want to know
The original.
population.
We want to know P of 0 equals question mark. Okay, here it is. Yeah, you're overthinking it. This is very similar to the other problems that we did in the sense that you have this slope. So here's the slope. Here's the point for 11,000. So the slope m is equal to 4. And we're just trying to figure this one out. So the way you would do this, basically you just work this out. Here's a point, here's a slope. Let me use y equals mx plus b language here because we're all familiar with that. Or I'll use y minus y1, keep forgetting that extra, is equal to m times x minus x1. Just make up, do your linear, since it says assume that the ant population is growing linearly. You have the slope, you have the point. So y is equal to 4x minus 16 plus 11,000 or 1100. So y is equal to 4x plus 1084. Is that what you would have recommended, Bryce? Or you would do it even easier?
Way more simpler approach.
Okay.
So P of prime 0 is the constant. So basically every day you're adding like 4 more people or whatever.
That's the rate at which the thing is changing. Very good.
Yeah, so for mine, I had 2 days it's known to be 1,800. So all I did was I did 4 times 2 and then subtracted that from 1,800.
Okay, so I'm going to do the same thing here. That's way easier than what I did. But I want to point out that I could have done this here. There's my answer. But no, yeah, I like your method is you just use your brain. Well, that sounds like the rest of you weren't using your brain. You have this clever idea.
Yeah.
I like it that way. That if in 4 days there's 11,000 ants, then and if this p prime just means you add 4 ants per day. So let's go back in time. There would be 10,096 ants on yesterday, 10,092 ants the day before that, 10,088, and then 10,084. Probably easier to do what Bryce did and just say we're going backwards 4 days. 4 times 4 is 16. Subtract, done.
It took me forever because that's the original way I thought it was saying, but then I was like, there's no way it's that.
It is that. This is all about rates of change. And so Bryce did the right thing and thought this 4 represents a rate of change. It's the rate at which the population is increasing per day. And we just have to sort of use that information. That's a beautiful description, Bryce. I love it. Thank you. It's oftentimes the case that what I do is way more complicated than what you need to do. And so I love it when you come up with these ideas. So do let me know when I do more work than I need to, because it's much more fun to just, figure out a trick. I love it. All right. So did that help with? Oh, Kelsey was the one. Kelsey and whoever else was like, thank you. It's okay. Today, I should mention this. The day before an exam, it's all about you. You choose what we do. And if this is what we do, great. If you want to move on to the chain rule, that is fine too. But we don't have to. I actually have a couple of quizzes here too. We could do for fun. I never collect quizzes the day before an exam. We just do them, we grade them, we're happy about them, and we go our way. So, anything else from this homework that we need to deal with? Oh, did I get that one right? I'm curious. I'm sure I did. Yeah, 1084. All right, what do you got, Ethan?
I was either way overthinking or way underthinking questions 9 and 10.
Yes, you were way overthinking them. They are just as simple as you would think. So marginal revenue function is just the derivative of the revenue.
Okay.
So do the derivative.
Oh.
That's it. So here, yeah, that's it. So negative 4q plus 900. Oh, I just hit enter. Did I get it right? Yeah, I got it right. Yeah, so that's it. Marginal revenue, that's it.
Wow.
And then this one, it's like, what's the marginal revenue at that point? So you would do that negative 4. Let's see, can I actually just type it in? I'm going to try this just for fun because, you know, I can experiment all I want. So negative 4 times, let's see, oh, it's not a decimal or integer. 181 plus 800. Okay, so apparently I actually have to do the math. That's sad. What's that going to be? 4 times 8, 32, 320, 724. So 724 subtract from 800 makes 76. Let's check it out. See if my mental arithmetic is correct. 76. Done. Yeah, so it is exactly that simple. Do the derivative, plug in the number, you are overthinking it. Yeah, so yeah, marginal revenue is just the rate of change of the revenue. Same thing goes with marginal cost, marginal profit. So these are just terms that the business school bandies about, but they have their roots in calculus. So there it is. What was that?
Overthinking is a common theme.
Yeah, through this homework. Yeah, it's all super easy. Well, I shouldn't say super easy. It's just that you have to have the perspective that the derivative is a rate of change. The derivative is a slope. And then use that in some intelligent way, like with the ants, or here it's the marginal revenue. All right, are we done with this? Did we do them all yet? There's got to be one or two that we didn't do. Do we need to do number 3?
Yeah.
Okay. I want to make sure we get them all. Are we good on 6? Yeah, what was 6? Oh, that's.
6 is just a derivative.
Oh, do the derivative and the second derivative.
Yeah, I got that one.
Okay, so 6 we're good with. This